All right, let's look at the other three functions. We looked at the identity, the squaring function, the cubing function. So now we're looking at, say, going backwards instead of squaring, we're looking at the square root function. So our function is going to be y equals the square root of x. So here, this is our first one. We're actually going to start with different x values. So I'm not going to start with -2, because if I take the square root of -2, we've learned that that's not a real number. Okay, that's what we call an imaginary or complex number. So we're actually going to start with 0, 1, and then also, instead of looking at 2, because 2 is not, if the square root of 2 is not really easy to graph, we're going to jump to 4 and next to 9. We're going to put perfect squares in for our parent chart. And so that's one thing you want to remember is you can really put any number in here, but it makes it a whole lot easier to graph by hand if you put perfect squares in for the x values. So then we get the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. And notice that we're only using the positive roots. These are called the principal roots, meaning that because we're not taking the square root, because our equation is not y squared equals x, in this case, when I take the square root, I have to include both roots. But when I start with y equals the square root of x, that is telling me right here, this function, because there's a no plus or minus in front, it's telling me I'm only looking at the positive roots. So let's look at the graph. 0, 0 is right here, 1, 1 is right here, and then I have to go 3, 4, 2, 5, 6, 7, 8, 9, 3. And so this is like half of a parabola. It's kind of been rotated over on its side. And so there's a couple things about this graph. It's our first graph where the domain is not all the real numbers. We're just going to have from 0 to infinity because we can only take the square root of 0 or positive numbers. Range is going to be the same thing, 0 to infinity. It's not going to have any sort of symmetry. It doesn't reflect over the x or the y-axis. So it's not even, it's not odd. It doesn't have any symmetry. We can see that it is increasing over its domain from 0 to infinity. And let's see, that's about it. Okay, so let's move on. Let's look at the cube root, which is really similar. So in the cube root, again, we're kind of going backwards. If I know the volume of a cube, what would the side length be? The cube root of x. So here, I can put negative numbers in. I can put any type of number in because I can take the cube root of a negative. But here I want to put in not perfect squares, but perfect cubes. So if it's really small, it's easy. The cube root, if I have a cube of 0, that has a side of 0. A cube of 1 has a side of 1. And a cube of -1 has a side of -1. But the next one, what would be 2 times 2 times 2? That'd be 8. Okay, so the cube root of 8 is 2, or -8. Okay, the cube root of -8 is -2. And so if I want to graph those, it's going to look just like my x cubed graph, but rotated 90 degrees. So now I've got to go back 1, 2, 3, 4, 5, 6, 7, -8 and up. Oh, that should be down here, -2, -1, -1, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 2. So there are my points. Missed. Something like that. This graph, you can see it's increasing over its whole domain, all the real numbers. And the domain and the range both are going to be negative infinity to positive infinity. And it is what we would call an odd function. Notice that all the powers of x were odd in our odd functions before. So like y equals x to the first, the identity, that was odd. Y equals x cubed, That's an odd number. That was an odd function, symmetric to the origin. Now here, y equals x to the cube root. That would be like x to the 1/3, which isn't exactly an odd number. So when we think about whether or not it's an even or an odd function, it doesn't just mean are the exponents odd or even. That is one way to tell if a function is going to be odd or even, but there's other types like this one where any particular point that we pick, so for example, this point out here, 8, 2, if I change the sign of both x and y, I get -8, -2. That's also on the graph, so it is considered to be an odd function. All right, and that leads us to, I think, our last one, which is our absolute value function, which is really just our identity function that we started with before, y equals x, but we're looking at all the values of x as positives, okay? All the values of x as positives. So whether I plug in negative numbers, -2 and -1, or positive numbers 1 and 2, the y value over here is going to look at what would be the positive value of that number, or the absolute value. The distance from 0 is really the definition for the absolute value. How far is that number from 0? Okay, so we're going to get the same exact thing on from the origin and to the right, and so on. But over here, instead of -1, -1, we're going to end up at -1, +1, -2, +2, -3, +3. And so my graph there is going to start at the origin and be kind of a V centered there at the origin. Okay. And let's see, what this, in some ways it's very similar to a parabola where the domain is all the real numbers, the squaring function, and the range again only goes to 0. It's exactly like the parabola in that the right side is increasing from 0 to infinity. The left side is decreasing from -infinity to 0. Remember, we can see that by placing any point along that graph. And as that point moves along the graph from -infinity to 0, the y values decrease. They get smaller and smaller and smaller until they get to 0. And then anything to the right, as I move from 0 to infinity, the y values get bigger and bigger and bigger. They increase. What's left? Symmetry. This also, it's not an even power of x, but it is what we call an even function because it has symmetry. It's symmetric to the y-axis. It's a reflection over that y-axis. When we look at the y-axis, we can see it reflects over that. And so this is just a reminder, every time we're going to graph, we're going to use these parent charts to think about what are the points on the graph and how can we modify them when we're going to stretch, shift, or reflect, or translate